always the development tool was human build, human verify, human refine. Now it is AI build, human verify, AI refine.
There's so many stories of enterprises buying software and spending months and even sometimes years implementing them.
So a lot of evolution is around how do you enable fast verification?
Maybe if you can share a little bit, what are the data related challenges that you see?
The fundamental core is still the same. You want to make sure that this data is clean. You want to make sure that this data is at one place, and you want to make sure that this, as new data comes, you can merge this data into that stuff.
So how does this change, how we are hiring people?
It changes completely. I'll give you an example of how we hire engineers today. We do a problem and see how they are using the AI to do the problem.
Hi everyone, thanks for listening to another episode of Data Innovators and Builders. Today I'm speaking with Ashish Thusoo, founder and CEO of CurieTech AI. Ashish, thanks for chatting with me today. Great to have you here.
Thanks, Saket. Great to be here.
Awesome. So let's get started, Ashish, with the latest stuff that you are working on, and share with us the problem that you're solving at Curie.
Yeah, so Saket, Curie is a very exciting firm that has started a couple of years back. And the core thesis around Curie is that how do we use AI agents to automate software development, but in a different way. We are really focusing on IT engineering. So we are really trying to reimagine how IT engineering is done today, and automate as many workflows as possible in our, using AI and AI agents around IT engineering. Every company under the sun has IT. Every company under the sun has various business systems, CRM systems, financial systems, and a lot of energy in IT is spent on making these systems talk to each other. Since this is data related, there's a lot of data movement that happens between these systems. And CurieTech is trying to, and a lot of this integration work is done today by IT engineers, and we are trying to bring a lot of efficiency using AI agents to this integration work. And that's where we have innovated. We have created a fleet of agents that go all the way from creating design specs to creating code to creating tests, and general life cycle that is followed by the IT engineers. And these could be things like upgrades. These could be things like migrations. These could be things like troubleshooting of what is happening in the integration and stuff like that. So it's a brave new world. As you know, the whole of software development is getting redefined, and we are focusing a lot on the IT engineering aspect of it.
Okay, no, that's very interesting, right? So IT integrations is basically working through all the different IT systems in an organization. So by which I understand the focus is not on the core software that a company may be developing as a product, but more like all the systems that they're trying to operate together, right?
That's correct. Yeah. So in the Valley, we hear a lot about companies who are building software as a product, but as you know, the economy just doesn't have those companies. There are a lot of companies who are, say, in logistics, in healthcare, and many other places where the product is not software. Product is something else. But all of these are common. All of these companies, the one thing which is common is, in order to run their businesses, they need various business systems. Those are managed by IT, and those are engineered by IT, and those are integrated by IT in order to make a lot of their business processes automated.
Yeah. Okay. So, Ashish, maybe for our audience, if you can give us a before and after sort of perspective of how has this been done so far, or maybe how are organizations doing this today? And then when you talk about an agentic sort of approach to solving this problem, what does life look like for your customers?
So that's a great question, Saket. So today, up till before this AI revolution that we are part of, and we are essentially using it as catalyst to reimagine how this work is done, most of this work was essentially done through engineers, whether they be inside the company or outsourced. And essentially, the workflow was, somebody would, the classic workflow of engineering, which is somebody would gather requirements, write a functional spec. An architect would take the functional spec, create a design spec, Then those design spec would get fragmented out to multiple different engineers who are working on parts of the problem. Then there would be a unit testing phase, then there would be an integration testing phase, and so on and so forth. So in all these phases, there is humans designing, humans building, humans verifying, and humans refining in all of these phases. Whether it is from figuring out requirements to design to build to testing to putting in production, all of those things is human interactions. Now with AI, that whole model becomes changes. So that whole model essentially, with human building and human verifying and human refining, changes to AI building, human verifying, and AI refining. And that has significant implications on how you do this type of work. The biggest benefit to the companies is that you can now compress these cycles significantly. You can get, like, with our software, for example, they can get 70-80% productivity improvement in many of these cycles, because the machine is doing all the build and the refining, and the human is essentially focused a lot on verifying. So this is fundamentally shifting how you do this work today. And it's fundamentally taking it to a much more efficient model. And the benefits from that to the clients is they can compress the amount of time or the cost. And at the same time, they can get much higher quality work done, where it used to be very, very, not as standardized previously. So fundamentally, if one thing you have to remember is the loop, always the development loop was human build, human verify, human refine. Now it is AI build, human verify, AI refine. And that itself, you can apply to any of these phases and between these phases, and really compress the time and the effort that it takes to build or maintain these integrations.
Mm-hmm. Yeah, there's so many stories of enterprises buying software, and spending months and even sometimes years implementing them and making them work for them, right? And this is true for complex like ERPs and sales software, marketing software, and so on. One of the things that you mentioned in the process was the spec part of it, right? And many times these specs are created by the business user, right? But the implementation is done by the IT team. You talked about the AI building it. How does this part of the interaction improve? Because there's a lot of communication between what a business team wants, what IT builds, and then there are changes. There's continuous changes in business, right?
Yeah. So that's a great question. So requirements gathering is an activity that happens. Fundamentally, when you're gathering requirements, it can happen in documents, it can happen in conversations, it can happen in meetings, it can be structured, it can be completely unstructured. There's a lot of variance that happens there. However, what is now happening is that AI is making its way into many of these places. Not all, but many of these places. For example, if you are doing a meeting today, there's an AI note taker which is able to transcribe that meeting. If you are, even, if you are doing conversations on Slack, there are now agents that you can, build onto Slack to read that information. Though you can't cover all and every aspect of where these conversations happen, there are obviously places where these conversations are happening. AI is being built in today. So that is one way of getting some information. But more fundamentally, the AI can help in, even suppose somebody has all this information in their heads, or few people have all this information in their heads. The AI can help in gathering that information from those people and then structuring it in a proper way. So if nothing else, it can help you structure your design documents and your functional specs in a way where it could have taken days, many times days, for people to just structure those thoughts. Even if you've gathered everything, just structuring those thoughts and writing them in a particular way where it is consumable, AI can help a lot. And that's where we our company also helps and has agents which do that. And the fundamental thing is that when you're writing these design specs for humans versus when you're writing it for machines to build, there's a lot more detail that has to happen for the machine build, because humans can infer, and even if you don't have the details, they can go and talk to somebody and say, get me the details offline. But when the machine is building those specs have to be a lot more richer. So, there the AI is even more effective in building out that level of detail, which if the human is doing it all by themselves, it won't get there. So those are the aspects where right from the designs, I know a lot of focus has been on AI development agents, which are actually doing the build of the software, but phases even in the designs phase, there can be a lot of benefits that AI provides, which people don't talk about much, but it is certainly a part of the software development lifecycle.
Yeah, I think that's absolutely true. Software engineering itself is changing with this, and it's not just the writing the code part of it; it is the full life cycle of the things. And I'd love to dig into that. But before that, maybe give me a bit of a perspective on, you've been building this over the last half 2 years, and you've probably seen a lot of evolution of AI itself along the way. Tell us, Ashish, like, from the outside it seems like AI can do everything, but in reality, when you are building stuff, where are you? Where did you see the limitations? Where have you seen things improve, and maybe where is still area of innovation to come?
Yeah.
Building with AI. Yeah.
Yeah. So great question. It's evolving. It's evolving rapidly. The first year when we were building things, even if you give the right instructions, the models used to hallucinate. I'm just talking about code building right now, not everything else. The models used to hallucinate a lot. Now that aspect has significantly improved, but it is still not at a place where you can take the human out of the verification loop. And I don't think that is going to go away uh, anytime soon. Because many times, even if what we have found is that even if, and we have fine tuned our own agents, dev agents for this particular space, which is a little different from the space that cursors of the world go after. This space is much more IT. The languages are a little different. The systems are different. The verification process is very different. All those things are different. So what we found is that even with all the work that we have done, if there are certain pieces of information missing in the spec, then the agent can get it wrong. So verification is super important. And while the first year was more about, hey, will anything come out, and most of the code development was mostly around code completion. This year now you can build more than code completion. You can do a lot of different things, but the verification itself is easier, but it has not gone away, and I don't think that will go away. So a lot of evolution is around how do you enable fast verification of what is produced by these agents. The agent architectures themselves, like we use multiple techniques internally. Agent, not just the models, but how do you how do you from these models get the right results. Those are evolving rapidly in many different dimensions. And then I think lately now we are seeing accuracy levels where it is manageable and people can use it for productivity. And now a lot of big part of conversation is also how do you do this faster and faster and faster. So I think that is where the future is headed to. How do you make verification much easier? How do you make these models give results out much faster than what they were able to do, they're able to do today? And the accuracy improvement continues to happen, but I think a lot of it is going to come not just from the model itself, but from the agent architecture around the model, which is where companies like us are innovating.
Yeah, model is a core piece of technology, but how you leverage it. And we have seen the same, like a lot of innovation in our space around that, what that agent architecture should be. To give an example, in some cases we found that having multiple agents doing small pieces of work is not as effective. Sometimes having an agent take on a bigger piece is better. We also saw, for example, that prompt and how you build that has a lot of impact on outcomes, and so on and so forth. So um, could you share maybe how you have sort of built that agent architecture, and where you might have seen certain approaches that are out there today, like MCP, for example, be effective or versus lacking, right? So tell us where you hit those limitations and what you solved there. Yeah.
Yeah. So building great agents, production quality agents, is both an art and a science, because there's no prescribed recipe. Yes, there are protocols like MCP and all, but that's not a recipe to build an agent. That's an ingredient
Yeah.
which provides the glue on some of the most important ingredients that go into building agents, which is being the LLM and the tools, right? So MCP allows you to do the glue. But how do you go about building the agents is both a science as well as an art, because there's no prescribed recipe. Typically, many people throw up an agent saying, okay, let me take LLM, give it the right context, rag some knowledge bases, put some tools in place, and I have an agent. And that's a great way of building prototypes. But when you go about building production quality agents, you have to first build out how you're going to measure uh, what these agents are able to achieve. What is your benchmark? And there's a lot of energy that has to go into getting high quality benchmarks and a high quality signal from those benchmarks, because it's very difficult to in structured data analysis, you are dealing with numbers, so you can know from numbers a signal is 0 or 1. But when, for example, you are in the space of code generation, or for that matter any other generation, which is by nature you know not as structured, it's very hard to say whether it is 0 or 1. So there is human verification that is involved, there is machine verification that is involved, there are agents that can do that verification as well. So first you have to lay that groundwork out, that how are you going to measure whether things are better or not. So we did that a lot, and we spent a lot of energy in that. And then once you do that, then you can painstakingly go through, we have to painstakingly go through every single error that our agent would make on those benchmarks, and then go about reasoning whether those errors are because the agent is not fine-tuned properly, or the model is not fine-tuned properly, or those errors are because it's in context. And that is a very laborious process. We have gone through that process again and again and again and again, and continue to do it. That's a never-ending process. And that then starts to crystallize around, okay, in this particular task for this particular agent, what techniques are working best? Do you need to increase the knowledge base, or do you need to build certain other tools, or do you need to fine tune the models because the base models themselves don't understand this domain? And we use a combination of that to actually build about those agents. But that is generally the process, and that's when you start to get production grade um, accuracy, which people can actually use. And we wrote a few blog posts about comparing our agents with a few other agents in our space that people out. And the mark difference is basically this painstaking process, which takes a real amount of time and energy to go through. So that's what we do.
Okay, I think I would 100% agree from our own experience doing that, and actually want to double click a bit into the fine tuning part as well. But before that, can you maybe sort of bring to life this example of you can have a simple agent, but then it's not as effective, and you have to have, I guess what you're saying is an eval set, benchmarks, sort of measure that. Could
One-
you maybe share a real example of, say, an agent maybe that is operating on a particular system, and where you saw it hit some issues, and how that eval set sort of helped you fine tune that architecture?
Yeah, we can talk about a few agents that we built. Some of the agents that we built is around the tasks are around upgrades. example, version upgrades. Now, when you're doing upgrades of, say, various, in our space, in enterprise IT, a typical IT department for a large company may have 1,000 business systems. At any time, some business system is getting upgraded or not. That upgrade might have implications on your integration. So upgrade is a upgrade of version change is a very important aspect. Now, this is a task. For this task, we have to first build benchmarks. The space of upgrades is large, right? So there's a lot of different systems. So, how do you go about first discovering the space? How do you, say, okay, how do you quantify that your benchmark is enough coverage around this? So we spent a lot of energy in doing that, and where we did not have coverage, we would, build these tasks to do the upgrades and find issues where, for example, in certain cases, some of our models, because this information about how to upgrade these things is not publicly available, the models would make reasoning errors. And so we would have to go and fix those, figure out whether we can fix those reasoning errors by providing examples to those models or by fine-tuning those models. So that is one very concrete example where you would get these errors. And the same pattern you would essentially see in a lot of other places as well.
Yeah, I think very well said. I mean, upgrade is a very big part of the IT job, and errors and issues can have significant impact. And I've seen cases where these upgrades go over months of time, right? So bringing AI to accelerate that, make it more reliable, I think that makes a very high value use case of applying AI, right? As we're getting into this, we're talking a little bit about fine tuning. That's something that we have seen also in some cases. For example, we fine tuned for a faster response to the user when they're working on things. So maybe let's double click on this a little bit. You know, how did you go about that process? Like, there has to be a data set to fine tune the model. What positive and maybe even some negative impact did it have? Does it we have seen cases where security risks might also change with fine-tuning models and stuff like that, from prompt hacking, for example. So would love to maybe understand a bit on that front.
So fine-tuning is a way for models. You rightly said, you essentially fine-tuned models in order to make sure that the response to the users is faster. So
Yeah.
today you can take the model and you can drag it with knowledge, which means that it comes to know about that knowledge at the inference time. It's like, I'm going to give you a book and you don't know the contents of that book. I'm going to give you an exam and you can open the book, do an open book exam, and you can write your answers. So that is the RAG stuff. RAG is your book, your knowledge base, and you have access to that book, and you're going to look at the question, look into your book, get the answer, refine it, and so on and so forth. As opposed to this, I would give you a book. You can prepare for it for a month. You can read it completely, memorize it completely, and then go for an exam. So your answers will be much faster. So fine-tuning is just that mechanism that allows you to do that. I see RAG and fine-tuning as just two ends of the spectrum. Many times you identify, you can identify things where you need much more. This knowledge is like, it's not fast changing. But you need fast response. You would go with fine-tuning. And if the knowledge is fast changing and it's hard to keep it up to date, you can't fine-tune the model every single day. You would essentially use mechanisms such as augmenting it with retrieval and doing it that way. So we see all of that stuff. Common to both of these is the data set. Again, a lot of AI now is how do you build these data sets. So just like we build benchmark data sets, we also build these data sets in a similar way to either RAG or to fine-tune things. Building these data sets may involve humans. We have also created synthetic algorithms to build those data sets. And there's a full process around how do you build these data sets, get them verified by humans, and you can apply a lot of science to it. You can, for example, you can take a sample of this data set and have humans score the sample, and from that sample, figure out how much of the synthetic data set is junk or how much is not, and you can use that to, train judge models to do that. So there's a whole pipeline that you can do to build those data sets, and at the end of that day, and you can throw different metrics to that data set. You could throw metrics around what feature set it covers in your particular domain. You could throw metrics around whether it is safe or not, can be hacked. Is there some information there which should not go into the training of the model, because things can happen. So all of those parameters happen there. But once you have this data set, then you can apply it to fine tuning, or you can apply it to RAG. That's just a spectrum. Again, lot of way of building these agents. Data is key. Data is central, and that is basically, if you think about us, we are much more of a data company as opposed to a software company, which is essentially building out this data in this particular domain, which gives us the advantage.
Okay. And is this the data about how this process has been built in the past and how some of these workflows have been created, or is this data from the system itself to validate, before after changes? What data comes into picture
So
here?
what we do is we identify a workflow or portion of a workflow and say, okay, this portion of workflow we want to do through the agents. So this could be, for example, portion could be given a spec, give me the code. That is one way. Or it could be given the code, write me the tests. It could be given the code, write me the documentation. So this is a very well-defined task. Now, for this well-defined task, you define what the input is. In case of a spec to code, it'll be the input will be the spec, and the output will be the code. Now you can build a lot of data sets around this, which means you have to build various repositories, you have to build specs, you have to build code, you have to make sure that these all match, you have to have positive examples of it, and that becomes a painstaking process. But once you do that, you have a very strong base of this data, and that then starts reflecting into how how good your model becomes or your agent becomes.
Yep. Yeah. So, Ashish, I think one of the things that I'm seeing is that you are sort of solving some of the most complex enterprise challenges within the IT space. And when there is a general conversation in the market about enterprise adoption of AI, are enterprises adopting AI and are they able to use it? And is AI effective for enterprises? I think a lot of that conversation is to what extent can AI help run the business itself, the day to day of the business, and how much of that adoption is possible? And it has been challenging, I personally believe, because enterprises are incredibly complex. You gave us an example of upgrade, and upgrade itself can be a complex process. So,
Yes.
um, maybe from your vantage point where you're seeing it, give us some picture into what are the real complications in the enterprise and how, in your case, you're bringing AI to those, and what is that roadmap looking like? It's some of these technologies are amazing, but actual adoption takes time, right? So, give us some picture into that. Yeah.
So the complications are both the environment, the technology, and as happens with the market, um, it's not at a place where every enterprise is ready to adopt AI as well. Much less this year than last year, but last year we would go and talk to companies and they would say, we are not going to use AI, but not this year. But still, I have met companies who say, hey, AI is no for us and things like that. So there is that people aspect of it. And I think that, so I'll touch all those three aspects: the environment, complexity is the environment itself, the technology itself, and the people aspect of it. Let's start with the people aspect. As happens with every new technology, there is a little bit of a skepticism. Then there are certain early adopters who adopt that technology and gain competitive advantage. Then everybody follows. This has happened with the cloud. This has happened with the internet. And I think now it is happening with the AI. And you can see the arc of adoption is actually much faster, much quicker than any of these things, because people get benefits. But right now, most of the enterprises are in the experimentation stage of, this is going to work. But there's a tremendous amount of, at least from the people side, there's a tremendous amount of will to experiment, because they can see the benefits. If this works, how it is going to be. Now, typically, let's talk about the environment itself. Enterprises internally are very, very complex, both in terms of the technology that they use. In terms of the processes are not very standardized. Some enterprise might be doing customer support in a certain way, another might be doing in a completely different way. Some enterprise might have a way of how your revenue gets from your sales systems. How does it get reflected, and when does it get reflected, and what is the approval process that it has to go through in your financial systems. Another might be doing it in a different way. So this customizability is super important, and that's why the richness of the agents is there. But if everything could be done with a single model, then you're basically saying everything is there's no customization. But because the enterprises are complex, you can't just take an off-the-shelf model and say, let me throw it to my customer service problem, or my support problem, or my sales problem, and it'll solve it by itself. You need to write software around it, an agent around it, and people are writing those agents. We are writing coding agents. We're writing the IT integration agents. And just like in software, you have to provide hooks to customize them. For example, in our case, when we are doing integration builds, we provide hooks for an enterprise to write a knowledge base of around any customization around naming conventions, or what should, so similarly, you can imagine there will be some customization, some knowledge base that can be written by the enterprise on what are the different stages of their sales process, for example, and how those, things transit from one stage to the other. So that is what is needed, and that is where the agents are starting to fill that gap. That is basically the way you solve the complexity of both the process as well as technology within the enterprise. The third part of the reason why you can't just throw a vanilla model. Many times people say, okay, let me just take a vanilla model and try to see if it works in my business process. The third part is, because of this specificity of the enterprise around how they do things, or the process and stuff, the data which captures this process is also inside the enterprise. It's not outside. And finally, the model feeds of the data. So that's why it becomes very important to also consider that custom data for that particular enterprise, whether it be in form of knowledge base, form of things. That is what the agents can go about. So we are still, on day zero of this whole transformation. But what is very encouraging is that there's a lot of willingness to, especially this year as compared to last year, there's a lot of willingness to experiment, and a lot of willingness to even change the way things are working. Like I described how CurieTech AI agents are essentially changing how you actually build integrations. Same thing is, how do you actually support your customers? That itself can change, make it more optimally for AI. But that is an evolution, and that is going to keep going for many years.
Yeah. And you mentioned along the way that this is very much a data problem as well. It's not just the application and the process side, right?
Mhm.
And maybe if you can share a little bit, what are the data related challenges that you see, and how does that impact? Is that fine tuning? Is that would love to understand.
So the data related challenges are the same that have been there previously as well, except on a grander scale. So we come from the analytics background. So analytics always used to be, hey, my data is all separated in multiple places.
Yeah.
That challenge is there. My data is not standardized. That challenge is there. How do you merge all this data together and make it correlated? That challenge is there. Now, agents and fine tuning are just another application of that data pipeline. The difference being that this data now is way more diverse. I described you the problem that we are solving about spec to code. This is very different from a data that you would get in a BI system, for example. But the fundamental core is still the same. You want to make sure that this data is clean. You want to make sure that this data is in one place, right? Not distributed. So there is a way of gathering all of these things. There's a way of cleansing, of making sure that this data is in a good quality metric. And you want to make sure that this as new data comes, you can merge this data into that stuff. So that problem is still the same, but it's even more critical. It was critical for BI systems, but even more critical now for these AI systems, because the AI systems accuracy is completely dependent upon what is the quality of this data. So those problems are still there, except at a much bigger scale.
Yeah, yeah. So I mean, it's all the stuff, right? It's the data integration, it's the data quality, it's the fixing the data silos, it's
Yep.
observability of that, it's the discoverability. One question I have, and curious if you see that as different from the analytics, use cases, was that in analytics you would pick specific data and say this is the data I want to use and do that. Whereas when it comes to AI, arguably you could open up any type of data in the enterprise and let AI figure out, whether we are passing it as knowledge or however, or as an MCP server or whatever be the interface to get to the data. It's like AI can go figure out what is useful for a particular case, right? So do you see that as like completely exploding the scale and complexity because you're not putting a human in the middle deciding what data to curate or not curate?
The complexity is because of the first thing that you mentioned. That you can ingest any kind of data,
Yeah.
right? Typically in the BI space, you would think about data in your systems of records, very structured. Okay, this is my system of record. Now you can think about and on the B2 side, on the B2C or consumer oriented industries, the data was far richer, and that's where all this big data thing came in, and so on and so forth. All that happened, but now there are now applications for that same unstructured data, which on the AI side, which resides inside an enterprise as well, right? So you can throw all that data to an agent or to a model, and so the scale increases a lot. And when we used to talk about analytics, it was structured data. Then we said it is semi-structured data. Now it is totally unstructured data. You can throw videos at this, you can throw pictures at this, you can throw completely unstructured conversations at this, which is the knowledge base of your enterprise. And so the scale, first complexity is because of multimodality of the data. Second complexity is when the modality is so diverse, how do you ensure the quality of the data? Yes, you can dependent upon you can, obviously people are applying LLMs to define that, build judges and so on and so forth, but judges are not perfect. So then you have to think about how do you improve the quality of the judges, and that's when the human has to come into the loop. There is no getting out of it, because if the human is not verifying it, how do you know? Well, there are other techniques also which are coming up, but fundamentally that verification is there. But doing that at completely unstructured data, where the quality metrics is completely different for this type of data, that type of data per task, for the type of task that you're defining, that particular data, the quality metrics could be very different.
Mhm.
So that explodes the problem, so to speak, of data quality. It's not a very well defined data quality metric. It also, so there is explosion due to multimodality of data. There is explosion because of this multimodality of data, the quality metrics change. And there's also, because of that size of both the data as well as the quality metrics, how do you and when do you introduce the human to actually do the verification? So it changes the problem quite a bit. But the end goal is still the same. You need high quality data to do all this kind of stuff.
Yep. Yep. One thing I would love to learn from you, Ashish, in addition to being, a technical expert on the AI side, your career has gone from one of the foremost people in the data world, from Oracle to leading and building data infrastructure at Facebook, back when very few people even knew what data is and what it is for, creating Apache Hive, which was one of the first, I think, SQL engines on top of big data, building Qubole as founder CEO, being the general manager of AI at AWS. You have seen the evolution over the last 25 years from foundational data to AI in such an advanced way, right? So I want to have you maybe zoom out a little bit and give us a picture of when you look at enterprises and when people are trying to figure out AI and how it will grow and work. um, what is the advice you have for founders and entrepreneurs who are trying to figure out, like, hey, I want to work in AI. What are the key problems to solve? How to go about it? Of course, you have identified an interesting problem yourself. So, yeah, would love your advice on that front.
So I think the whole AI revolution, if you see for the last 2-3 years, has gone from focusing on models to now focusing on agents. And I think the future is around how do you productionize uh, these agents. I don't think the infrastructure to productionizing that agents is there uh, today. So if suppose you see a sprawl of agents, how do you make sure you can control that sprawl, what they're doing, how do you verify what they're doing is correct? How do you govern those things and stuff like that? So this is following the same arc of think of agents as a new application type in the enterprise, new enterprise app. The enterprise apps used to be, business apps, then SaaS came, and now there are agents, which is happening. So in this new world, imagine the world, completely different. Everything is being done through agents. There are opportunities in infrastructure, like core infrastructure. How do you run this in a good, in a efficient way? There are opportunities in governance infrastructure. There are opportunities in security infrastructure. Whatever was applicable in what happened with SaaS in the enterprises, same thing is now applicable in agents. So you can, one very simple way for entrepreneurs to think about is, okay, what are all the problems that were hit during that arc?
Yeah.
Those are the same problems, but at a much bigger scale and at a much more probabilistic scale that you will hit in this particular arc, and you start creating those ideas. So that is one arc of how you can follow this stuff. The second thing is, now with the LLMs, there's this new processing unit which allows reasoning to be embedded into your workflow. Previously software was dumb, right? Software would do what was encoded in those instructions. It could not reason, and all the reasoning was done to humans. So now there is a big opportunity to rethink just the human workflows within the enterprises. How do you embed these reasoning components at different places, and how do you change those workflows, fundamentally making them much more compressed, much more efficient, much more productive? So that is the scale which that is where enterprise applications, new agent-based enterprise applications can be created, like the ones that we are essentially creating with our agents, or rethinking IT engineering. That the same. So there are these two arcs. One arc is agent proliferation. Agent is a new app, and as this new apps proliferate, what can you do in the enterprise domain, from the infrastructure, governance, whatever happens in app deployment process? How do you do that? And the other arc is, because the processing unit, there's a new processing unit, just like in SaaS, there was a new unit called internet, and you could deliver it. The delivery very simple. Now reasoning is becoming very simple, and when reasoning becomes very simple, how can you reimagine the old ways of doing things into new enterprise apps? And that is another arc. And both these arcs can lead to a lot of innovation and a lot of new ideas that can bring a lot of productivity benefits to the enterprises.
Yeah, I think that's very right on. If I think about this and maybe extend it a bit further, two important things you mentioned was one, human as a verifier in how you are building software, and the other part was human as a judge, right? Now, so if we take that piece and we say, okay, AI can do reasoning, are you imagining that AI can reason, figure out how to solve a problem, humans verify and judge that, does that go back into some sort of reinforcement learning and sort of further advancement of things? So maybe paint a picture for us, like how do you see software and enterprise workflows and all of these progressing?
So I think what is happening right now is, uh, there are certain ways of doing things in enterprise which defines their workflow. The first thing what is happening is, parts of these workflows, the agents are coming in. And for example, let's take support as a good example.
Yeah.
Workflow was a support ticket would come, a level 1 support person would look at those support ticket, triage it, look up a knowledge base. If they were able to find an answer, they would give the answer to the user or fill out that ticket. If they're not able to find the answer, they would go ahead and give it to a level 2 person. They would do a lot more digging and so on and so forth. So that's one process of how support was doing. Now that is getting heavily disrupted by agents, where the level 1 work the agent is able to do because now they can reason. They have the knowledge base, they can do the reasoning and stuff like that. However, can you let this agent be by itself and do everything? No. So what happens is, as it is doing this reasoning, you provide verification, human verification on at least some sample of its reasoning to make sure that it's going in the right direction. And that feedback can go back into improving its reasoning for that particular use case, for that particular for that particular stuff. Some of it will get subsumed in the fundamental models itself. Some of them would be very enterprise specific. And that way you keep optimizing these units. But another bigger opportunity is, if you can, turn the support on its head now, where you can, instead of waiting, sometimes you have to wait for the user to give the error and things like that. But suppose you deploy a lot of agents which are doing verification internally and proactively reach out to users to support. Now, if you are deploying machines to do all this stuff, it is much more doable. So support process itself can be changed, whereas proactive, before the user hits the problem, you have already fixed the issue or provided, anticipated an issue and provided it to the user. Now that becomes a realm of possibility. Whether that will happen or not, time will tell. But this is a fundamental way, which an illustrative way of saying, okay, how does support fundamentally change with AI? So right now we are in a place where there are ways of doing things right now, and AI is augmenting those ways, making them more efficient. But I think there's also an opportunity of really rethinking each of these workflows that happen in the enterprises. Now that you have this ability of reasoning at scale, not through people, but at scale, you can throw a lot of AI to it. How do you change that completely? You could have your agents monitoring your internal systems, figuring out there's a problem, handing it off to another agent, a support agent, which has that information, identifies the users that might have this thing, and proactively using out to them. You're turning the support problem from inside out. So these are just examples, and how this will pan out, only time will tell. But I think these are opportunities now, because there's fundamentally new technology that enables you to do this.
Mm-hmm. Yeah, I think this whole approach where maybe the tasks are being broken down and the agents sort of running those, um, yeah, seems very promising. So I've also seen sort of challenges in terms of getting the quality and reliability high, but I think that's kind of one of the areas of improvement. That reminds me of one of the papers that came out of Stanford recently about agentic context engineering, and how the proposition at least is that no, you may not need to fine tune models, and you can have cases where you're doing reflection on prompts and outcomes. And are you sort of suggesting in that direction where agents are looking at outcomes and improving the prompts? And how do you see that perhaps fitting into this?
So hard to say
Yeah.
where it will go. Um, there's a lot of work which is happening in improving prompts themselves based on
Uh-huh.
the outcomes. At the end of the day, all of these techniques boil down to some feedback, some way of verifying, and some way of telling the agent or creating a data set which says, this is good, this is bad.
Yeah.
So today, humans are doing it. You put agents to do it, or you can create loops like this, where the agent itself is the same agent is self correcting it.
Yeah.
Now you have this reasoning unit. You can apply this reasoning unit any place.
Yeah, absolutely. So how does this change, like, how we are hiring people, training them, managing them, like with all of these agents in the mix then?
It changes completely. I'll give you an example of how we hire engineers today. We
Yeah.
make them do a problem and see how they are using the AI to do the problem.
Okay.
We don't actually, we obviously ask them to, check their fundamental understanding of algorithms and systems and things like that. But the best thing, the most important thing that we do is, here is your dev environment. You use whatever you want. You want to use Cloud Code or Cursor or whatever for generic programming, what you want to use it. Here's the problem. And we then look at how they are guiding the AI to build.
Yeah.
It is a very different skill set, and it's a very important skill set to have in this future world. So I think the same would apply, to other aspects of hiring as well. If you are a marketer, for example, and you are creating content, instead of being able to write all the content and stuff like that, I think you should get evaluated on how do you generate that content using AI.
Yeah.
Much better, and so on and so forth. So a lot of creativity of how you break down the problem is important in that sense, as opposed to how do you actually build the asset. That is becoming less important.
Yeah, 100%. I mean, I believe that the best hires are people who actually know for their area of work what a good outcome looks like. And
Uh-huh.
then they can use AI, break down that task, and have AI help them get close to that
Good outcome.
ideal outcome. And then they can sort of, do the necessary tuning and adjustment. But in that process, they have become that much more efficient. They're probably producing, maybe if you're a marketer, 5 times more content in the same time with better quality even.
As easily. So you can imagine the
Yeah.
amount of productivity that happens.
Yeah.
And this is very well put, Saket. You go from they know what a good outcome is, and they're able to then make the AI build that
Yeah.
output for them at a much
Yes.
faster scale and a much better quality as well.
Yeah. No, so this is great, Ashish. Now, of course, I can go on chatting with you and learning in the process, and I think it's a great learning experience for our audience as well to listen talking to you. So, I want to wrap up with this one last question. Is Since we talked about people and what are the skills that are important, maybe tell us what skill is important for entrepreneurs. You've seen the whole cycle of product to business and sales and scaling and everything. Tell us what will help entrepreneurs succeed. Yeah.
There are certain things which have become much easier for entrepreneurs now, and there are certain things which they need to adopt in this new world. The easier part is, previously it would take a long time to research things and, find out if you have particular idea, it would take a long time to research. Now with so much of AI technology, which is able to summarize a lot of public research quickly, research, for example, has become much easier.
Mhm.
But what is more difficult is that the rate of change of technology is so fast that back in the day, 20 years back, you would take a idea, you work on that idea for 3-4 years and build a big company. Now that is not possible. you know
Yeah.
if you were to come with a point of, oh, I'm going to work on this for 3 years and then take out a product, you'll be irrelevant in a period of 3 years. So the core skill for the entrepreneur right now is to be very, very agile with their ideas, and look at the arc of technology, where it is going, and shift based on that and identify this. A good thing is, when there is so much fast change, there is opportunity. Opportunity also arises very fast, but then you have to operate with a mindset of being able to very quickly identify those opportunities and change rapidly
Yeah.
around those things. So I think that is very important for entrepreneurs now. Everything else follows. The tools for starting companies now is much easier. The tools for creating great companies, or the ability to create great companies, is much harder, just because the arc of technology is is changing so rapidly.
Yeah, very well said. I think the baseline definitely has moved up, right? I mean, any idea that you can think of or come up with, by next day, there are probably 20 other people doing that. But agility and adaptability is still going to be the test of time. Like, who can keep doing that, not for the one first time, but, month over month, and capture value out of that, right?
So true. That's
Yeah.
absolutely right. Yeah.
Well, this has been a fabulous conversation, Ashish. Thank you so much for taking the time. Really enjoyed this discussion.
Yeah. Thanks, Agit. Really enjoyed the discussion as well, and it was great talking to you about these topics.